ask you, Yumeng, is how much public consultation do you do? Do you involve the public? Do you go to people and say, would you use a service like this? So she says not really. But actually, that's a key thing to know, isn't it? Is would your granny use this service?
Because I'm in my first year of my PhD, so if I, in the end, could develop this kind of public transport systems, I will ask my granny if she wants to use the public transport system. Yeah, I will ask everybody here.
Because this is an absolutely key thing, isn't it? That you involve the public in some of these decisions, because I suspect that you have industry saying they'll never go for it. But actually, it may be exactly what they want. And actually, if you have public demand, then it pulls the system to work for you. Any thoughts or questions about those 5 really excellent presentations? Sir, I'm going to ask you. What did you think?
Well, first of all, very interesting subjects. I'm interested in the subject of energy harvesting, because there are many applications where we need energy for sensing at spaces where we don't have energy, and there is always mechanical movement around air or mechanical movement, and very interesting to see that you're working on those things, and there is a high interest in those areas.
So there you are. I think you should be talking together in the...
That's what we will do.
Any other thoughts? Stefan, you're kind of an engineer and a mathematician, and you're all of these things.
Thanks. Yeah, trying my best. So yes, I mean, I thought it was exactly in the field that we're working on with Professor Cillian. So this is really exactly computational mechanics. And I thought during the talks on contact and on energy harvesting, I thought also of Goodyear, obviously, and yeah. So that was something that came to my mind immediately, and then I thought maybe that should lead to discussions afterwards. In terms of the complexity of the modeling, I think this is largely underrated, because there are a lot of difficulties again in the acquisition of the data. But in that case, the data is not necessarily a flux of information that is fed continuously, although this is happening for tires on trucks and so on. But what I'm thinking about is more the data for the engineer, creating the CAD file, solving the problem after generating a mesh, which was talked about during the presentation on contact by Diego. And I think this is something which takes really a lot of the human effort, something like for simple analysis, maybe 80%, and not a lot of, I mean, a lot of effort is put in, but I believe that because the market is completely fragmented and there are lots of people working in using different tools, and there are in-house tools as well, it would be really a potentially strong direction to investigate in terms of more computational sciences, not so much data science maybe. How to optimize and these relatively simple things which take a geometry and come up with a solution. But I think when we are a PhD student and we try to do that every day, the difficulties are not so easy to overcome, although it seems very mundane and very day-to-day. So basically what I get out of this is that even very simple things can be complicated, and that we don't necessarily need to go to huge databases and huge data fluxes to have already a lot of trouble to solve problems. For example, using contact mechanics for large deformations of composite materials. I mean, this is something that's quite tricky. So conclusion, maybe we should think of again an integrated approach to do this, as opposed to being to all work in using different tools, which is already very difficult in CAD. Not to mention simulation. So perhaps open source is a way, trying to come up with a common language. I think here in Luxembourg, again, we're in a very fortunate situation because there are companies such as Goodyear here located internally there is a university with strong people that just talked today, and others. So I think this is something that's just going to take some time, but it's going to happen eventually.
And what's interesting is whether because you talk about all the many models and being used and how different people are doing different things, and there's in-house efforts as well, has anyone ever thought about auditing what's actually out there? Because it seems that until you have data, you don't know really what's going on.
Yes, and I have no idea at all if that has been audited or not. So,
anybody, any ideas? And I was also going to ask Diego, so you're able to essentially know when additive manufacturing is going to result in a crack or it's not going to work, it's going to be fall apart. So can you build an algorithm with somebody that will predict whether that will happen a long time ahead? That could be part of additive manufacturing machinery. So it would tell you before you even started, don't be stupid, this is never going to work. I'm translating there.
So, but you were referring to fracture mechanics and...
Do you see what I mean? That on the one side, you've got something that tells you when it's likely to go wrong.
Yeah.
You know what the...
Fracture mechanics is not specifically my area, and I've been working for 1 year. I'm a second-year student. I've been working 1 year with contact mechanics, and about fracture mechanics, I don't know much, but my guess would be yes. I don't know if anyone could confirm that, but for sure, everything we do is trying to predict.
It was your...
Yeah.
I'm guessing the wrong person. I'm so sorry. He's taking over your project.
Not exactly. So, yeah, there have been some efforts. So first of all, if we specifically talk about this fracture coming into being during the manufacturing. So the kind of the optimization algorithms, which are already there, and there are some efforts, ongoing efforts, I would say, to kind of synchronize it with the printing process, whether it is for the polymers or the metal additive 3D printings. So the objective here is the same as you asked, to kind of give the user an idea that do not go into this way. So, but it's
Stop it.
yeah. So as I mentioned earlier, it's ongoing. Yeah.
So lots of areas of fruitful collaboration there. Maybe you could even do.
Actually, in our in our group, one of the PhD candidate is also trying to kind of have some algorithm or a working workflow to have this artificial intelligence, or at least the machine learning, being implemented in this physical laws which are being used in my simulations. Yeah.
By the way, you do know that the algorithm that Jeff Bezos has, you've all experienced this, haven't you? I'm quite sure that Jeff Bezos and Amazon have developed an algorithm which means that the minute you start a Zoom call, that's when the man from Amazon comes. That's how he does it. Anyway.